Alright guys, so in today's episode we're going to be talking about a little thing called Arcsine, which looks like this. Arcsine of x is going to give you theta. Also looks like this. Now these two forms are literally saying the same thing. They're both arcsine and they're both inverse sine. They're just a different way of writing the same thing. And so what these basically represent is sort of in the name, inverse sine. It's like the inverse of taking a sine of an angle. So if we have a sine of an angle, we're going to get x. X is a ratio, right? So if we look at this, if we plug that in, we take the arcsine of a ratio, we're going to get the angle. So let me do this again. We have 90 degree right there. We have angle theta. We take the sine of this angle, we're going to get the ratio x, right? So now the reverse is true. When we take the arcsine of the ratio, we're going to get the original angle. So that's fairly simple. So if we do a quick example problem, we know that sine, let's say, we're going to do this in radians, by the way. Get used to radians. If you guys have not been doing radians, get used to them. We're going to do sine pi over, let's do something simple like 6. We take sine pi over 6. Well, we obviously know that that's 1/2, just from basic memorization of trig identities. We also know that the reverse must be true as well. Arcsine of the ratio, which was 1/2, right, must yield the original angle pi over 6 radians, right? And that's pretty easy, I think. Oops, sorry about that. Oh. So I think that's pretty easy. Let's do another quick example problem. Except let's not think about it. Let's just do it really quickly. I mean, let's think about it, but let's not do the original sine thing. We're just going to do real quick. Sine -1 of, let's say, rad 3 over 2 equals theta. Quick, what angle in radians is going to give us, if we take the sine of that angle, is going to give us a ratio of rad 3 over 2? Well, we know, obviously, that it's going to be pi over 3, or, so that would be radians, or 60 degrees. That's rad. Alright, so that's pretty simple. Now we're going to move on. And now we're going to discuss a little bit of constraints here. Now, I don't know the reasoning for the entirety of these constraints. I do know part of the constraint. I know how to explain part of it. So we have the domain, and we have the range, right? So domain is obviously a constriction, or domain is obviously the restriction pertaining to the input, and the range is the restrictions pertaining to the output, right? Usually it's x and y. So for the domain, our restrictions are that x has to be between -1 and 1. And this actually sort of makes sense. If you actually draw a right triangle, and we have angle theta, and x has to be the ratio, right? And we know that sine is going to be opposite over hypotenuse. And another thing that we know is that the hypotenuse will always be, the hypotenuse in a right triangle will always be the largest side, in the actual shape. So if we have a smaller side over, a larger side, we're always going to get something that's less than 1. And the same holds true where if we have, our plane right here, and we have a negative, let's just say a negative side over a positive hypotenuse, the absolute value of that is going to be less than 1 as well. So now we're going to move on to the range. If we have theta, we know that it's going to be, and well, I know, you don't really know yet, and I'm going to tell you right now, theta has to be between -pi over 2 radians and pi over 2 radians, also known as -90 degrees and 90 degrees. Now, I don't know the reasoning behind this entirely. I thought I did, and I tried explaining it in my first attempt for this video, but I think I was wrong, so I just decided to redo this one. I don't know the exact explanation right now. If I find out later in a future video, I might, include that. But for now, just know that the range pertains to the first and fourth quadrants. Hypotenuse, rad 3 over the hypotenuse 2. And if we just kind of remember our 30, 60, 90 triangle, we're going to be able to tell that this is obviously going to be sine, or sorry, that the side is obviously going to be 1 because it's a 30, 60, 90 triangle, as we can obviously tell. Which means that which means that theta would obviously be what would that be? Sorry, pi over 3, right? Or 60 degrees. Because 60 degrees, the opposite side of that will be rad 3 in a right triangle. So now we're going to continue on to another problem. I'm doing these really quickly because I don't want to keep these videos super long for you guys. I'm going to write this another way. Sine with the -1 thing. So inverse sine of, let's do a negative. So we're going to do negative rad 2 over 2. Remember, that's the ratio. And that's going to give us an angle theta. So we're going to do our little thing. And we know it's going to be either in quadrant 1 or quadrant 4. Now, if we think about this, if this is a negative ratio, we're going to tend to think it's going to be in the 4th quadrant because we can't think of any angle in the 1st quadrant that's going to give us a negative ratio. That if we take the sine of it, it's just not possible. So obviously, it's going to be in the 4th quadrant. If we draw a little triangle in the 4th quadrant, a little right triangle, it'll actually make sense as we draw it. So if we have theta right there, and if we have negative rad 2 over 2, we know that this is going to be negative rad 2 because that's the opposite. And then the hypotenuse is going to be 2, right? And the hypotenuse will always be positive. And in the 4th quadrant, the y value, as you can see, if it's going down, that's going to be a negative, right? And so that also kind of makes sense. So let's just think of this in terms of the absolute value of -2 over 2. If we take the sine, or sorry, the arcsine of that, which means what angle, if we take the sine of that, will give us will give us a ratio of rad 2 over 2. And from basic memorization of trig functions, we're going to know that that's going to be pi over 4 or 45 degrees. But that's if we took the absolute value or the magnitude of the ratio and we found the angle, the original angle from that. That is not the correct answer because, as we can see over here, that is negative, right? Negative. Very important when you see this. All you have to do basically is just make that negative, right? So theta, because since this is going clockwise, it's going clockwise, right? Clockwise, which means that, well, we know in general, well, actually, you may not know yet, but you should know that whenever we're given an angle, unless it's otherwise specified, we're going counterclockwise. If we get a negative ratio, and it's in the 4th quadrant, we're going to be going clockwise, which means it's going to be a negative angle. So that would be what? What would that be? That would be negative pi over 4, right? Negative pi over 4 or negative 45 degrees. And that would be your answer. So negative pi over 4 radians or negative 45 degrees. And that's about it for this episode, guys. Kind of quick. I kind of went through those fast. If you guys have any questions or any problems you're stuck with, feel free to shoot me a message on YouTube, email, Instagram, Twitter. I'm available, and I'll try to respond as quickly as possible and answer to the best of my abilities. So that's about it, guys. Thanks so much for watching, and I hope this helped. See you next time.